Hi guys, Ms. Bohart here with the Gulfport School District. Today we are going to be learning the area of parallelograms. All right, and today we are using a PowerPoint from Ready Common Core Teacher Toolbox. All right, so if you have that, go ahead and follow along with us. Our learning target for today: finding the area of right triangles, other triangles, and special quadrilaterals and polygons by composing into rectangles or decomposing into triangles and other shapes. Apply these techniques in the context of solving real-world and mathematical problems. Now, this is a lot in one learning target, so we're not going to cover all of it in today's video, but we're going to get started. All right. So, we're going to start with some different shapes, okay? So we have same and different. We have a rhombus, a square, a rectangle, and a trapezoid. Now, let's just go over about how these shapes look. So, if I have a square, we know that a square has 4 equal sides, okay? And they all have 90-degree angles. We have a rhombus, kind of looks a little like that, where we know we have at least 2 pairs of parallel sides, but it doesn't have to be 90-degree angles. All right? We have a rectangle. A rectangle has 2 pairs of parallel sides, but all angles are 90 degrees. And then we have a trapezoid. This one looks like I'm going to have to draw, so bear with me. Now, there's different types of trapezoids, but trapezoid has a base 1 and a base 2 of different lengths, but they are parallel to each other. And then we have usually 2 other lines that connect the two. So even this right here, we have 2 parallel lines, but just because it's turned on its side, it is still a trapezoid. All right, so let's go ahead and get into this, and let's all right, Kenji and Alec are making paper kites for a kite flight. Kenji's kite is a rectangle. Alec's kite is a parallelogram. That is not a rectangle. Each boy draws a model of his kite on a grid paper. So if you have your grid paper, go ahead and get that out now so that you can draw your shapes. Let's go ahead and tear apart this problem and see what we need to know. So if we're looking at this, we know that Kenji has a rectangle. So let's go ahead and draw that rectangle. So I have my rectangle there, which is Kenji's. Now, we know Alec's kite is a parallelogram. That is not a rectangle. So that looks like some important information. We're going to go ahead and highlight that, okay? So we can have any sort of parallelogram. Remember, a parallelogram, we have 4 sides in that. So it can be kind of whichever one you want. I am going to go with a square. All right? So we have, it just says it is not that. So that is Alex. So we're going to draw each of those on a piece of paper. If you don't want a square, I want you to go ahead and take this time to draw your own parallelogram for Alec. Again, yours can be a little bit different than mine as long as it is a parallelogram. I'm going to give you a minute. All right, so you could have used a rhombus. All right, So if you use square or the rhombus, I'm going to go with the rhombus because that's about the only other one, and we can go into this next part. All right. Does Alex's kite use more paper than Kenji's kite? Okay, so, excuse me. If we have this and we're looking at our rectangle, and we have our other parallelogram, so we have to figure out if it's using more or not. So if we are using a rhombus, we can look at that and we can turn it to where it kind of looks straight like this other one. Now, I see that the sides are not straight, but I can go and I can kind of visualize this right here. So I kind of have made me a rectangle. If I were to, I could cut this piece off right here, and I could put it on this side right here. So now we can have one that looks like a square or close to a rectangle because we're cutting one piece off and putting it on the other side. If you have your grid paper, you'll be able to follow along and see that. All right, so let's keep going. How would you explain what the problem is asking you in your own words? So, I'm going to give you a minute. I want you to think about what this problem is asking. Go ahead. I want you to write it in words. All right? So we know that this problem is asking which kite is bigger. Is Alex's kite bigger or is Kenji's kite bigger? Now we're going to have to go through using our grid paper in order to figure this out. Does Alex's kite use more paper than Kenji's kite? Explain. Now I'm going to kind of put a little bit of a grid on here so that we can put our shapes on there. It's not perfect, but it does the job. All right, so if I am looking at this, let's go ahead and put our rectangle on there. So we have a rectangle on here, and we need to find the area of that rectangle. Remember, a rectangle is base times height. So if I'm looking at that, we see that we have a base of 1, 2, 3, 4, 5. So my base equals 5 and a height of 1, 2, 3, 4. So my height equals 4. We're going to take those numbers and we are going to plug them in to that equation. Okay? So in place of the b, I'm going to use substitution and put it in there. So we would have 5 in place of the B and 4 in place of the H. So if I'm looking at that area, 5 times 4 is 20. Now we know that we are using centimeter square units because this is a centimeter sheet of grid paper. So when we multiply together, we would have our centimeters squared. Okay, so we know that our triangle, our rectangle is going to be 20 centimeters squared. Now we have to look at the other one, the rhombus. Okay, so take a minute, write this down, and then I'm going to remove the rectangle and do the rhombus. I'll give you a moment. Okay, so let's go ahead and do the rhombus. So I'm going to just take my rectangle, move it down here, and we're going to draw the rhombus. So we know this one was a 5 by 4, so let's kind of have the same idea of the rhombus being 5 at the bottom and 4 up. So we have 1, 2, 3, 4, 5. Go. 2, 3, 4, 5. So we know that these are offset, and we're looking at that with a rhombus. It is the same formula, base times height. Okay, so we count on our base. 1, 2, 3, 4, 5. So we know our base is 5. And when we're going for that height, it's going to be from the corner down. So this right here is our height, and we would count that. 1, 2, 3, and 4. So we know that that is the height of 4. Remember how we talked about taking these pieces right here? And I could cut that off and come put it on this side, and it would make it look like a rectangle. So if I'm doing my rhombus, or the other parallelogram would be base times height, which my base equals 5 and my height equals 4. So we're going to use substitution to plug into that equation. Okay, so we have our base 5 times our height 4, which equals 20. And we always need our unit of measure. And like we said, these are centimeters. So we're going to put centimeters squared on the back of that. All right, so let's see if there's any more part of this problem that we really need to figure out. All right, so if we're looking at this next part, hold on. We know that both have about the same area, even though they're different shapes, and it looks like one has the other, they're both the same because of the formula that we're using. The words length and width are often used to describe the dimensions of a rectangle. When describing the dimensions of a parallelogram, you use base times height. Any sides of a parallelogram can be called a base. You can draw a corresponding height inside or outside of the parallelogram. And the base and height are perpendicular. Just like we said before, we go from the corner and all the way down, and that's going to give us our base. Okay, just because it's not looks like a rectangle, we can still use our base times our height. All right. So any side of a parallelogram can be called a base. Remember that. Any side. This side can be the base, or the top can be a base. All right? I like to think of the one kind of closest to the bottom. It helps me remember it. You can draw a corresponding height inside and outside the parallelogram. The base and height are perpendicular. Now remember, parallel runs side by side. Perpendicular they meet at a cross point. Okay? For each parallelogram, draw and label a height that corresponds to the sides labeled as the base. Then write the length of the base and the height. So here we have a parallelogram. All right? So looking at this parallelogram, we see that we have a base. When we're counting that base, we're counting each square. So we have 1, 2, 3, 4, 5. So everywhere there's a line, and there we're counting those spaces. So we know that it has a base of 5 units. Now, we're going to go from the corner, which here's a corner, all right? And we're going to go all the way up until it meets another base. And then we're going to count those units that way. So we've got 1, 2, 3, 4. So we know the height is 4 units. Okay? Now, in B, I'm going to give you a minute to try this one by yourself. Remember, it has the base labeled for you, and when you go to find that height, you go from a corner all the way to the opposite side. So go ahead and take a minute and do that one. All right, let's go ahead and go over that one. So if I'm looking at this base, I see that I have 1, 2, 3, and 4. So our base is 4 units because we're counting the spaces in between there. All right, then next one, we're going to go from the corner and draw a perpendicular line of the base. Remember, perpendicular means that they cross. Okay, and we're going to count those. So we have 1, 2, 3, 4, and 5. So we know the height is 5. Now remember, it's okay that they turn it on their side as long as you know that the base and the height are perpendicular to each other. All right. In problem 2a, would the length of the height change if you measured it from a different point on the same base? So if we're going back and looking at that, and we're looking at A, and we measured it from here, and we got 4, but what if I took it from here to the top? Would it be the same? Yes, it would. All right, if I took it from this corner, would it be the same? Yes, it would. Okay, the only spot where it's going to be a little different is if you're not sticking at a corner at the highest spots. Okay, so I want you to think about that, and I want you to explain. So use words, write in a complete sentence, capital letter, period at the end. Restate your question in your answer. I'm going to give you a minute to answer that. Go ahead. Okay, so when we were talking about that, we drew it in a couple different spots, and it was still the same. So if we are answering this question, would the length of the height change if you measure it? No, it wouldn't. Because remember, those opposite sides are parallel, and those parallel are the same length away from each other. For them to be parallel, they have to stay the same length all the way through. Now, I want you to take a moment and kind of fill this out. We're talking about area here. I want you to write a sentence about what area is. all right, what you know about it, and give a couple examples of area. Go ahead and take a minute to fill that out. If I go too fast, remember you can pause the video to remember to fill it out and then unpause it when you're ready to go. Remember, if this was not enough time, please pause the video and continue to fill out your chart. I'm going to go ahead and go over it. All right, what is area? Area is space in a 2D shape. Now remember, I started with my capital letter, I ended with my period there. All right, what do we know about area? We know that area has to do with 2D shapes, period. We know that area for a rectangle is base times height. All right, now let's go ahead and do some examples. I want you to think of 3 different examples, whether it be a rectangle, a rhombus, a square. I want you to come up with 3 different examples. Remember, your numbers might be different than mine. Go ahead. So we could have one, remember when we go to find that area, we might have one that looks something like this where it is a grid, right? We have that grid there. It can help us find the area. All we have to do is count those squares, right? So we have 1, 2, 3 on this side, 1, 2, 3, 4, 5, 6 on this side, which would give me my 18 units squared. Okay, so we can do our grid by counting everything. We can also have a rectangle that just gives us our base, which let's say it might be 5. Say it might be 5 and my height be 2. Remember, we've got base times height. So my base is 5. I'd put it in place of the b, which is substitution. Bring down my multiplication and put my 2 in place of the h. Remember, we're using substitution to put it in place of that variable. So we would have 5 times 2, which would give me 10. And remember, you always need your unit of measure. So we have 10 units squared. That's another example of doing area. Now this next one, let's say we have a square. Okay, remember square, all 4 sides are the same. Now, if I have inside here, it gives me that I have 25 units squared. And say I put a 5 over here. We can use the opposite operation in order to figure out that missing piece. Remember, opposite of multiplication is division. If we're looking at our fact families, and we know it's base times height equals our area, we have a base times our h we don't have. So we can bring down our h equals our area, which is 25. Okay? So we have to use the opposite operation to get that h by itself. All right, so I would divide. Opposite of multiplication is division. I would divide both sides by 5 because what I do to one, I do to the other. Okay, so that cancels that out, leaves me with h, and I have a fraction bar there. Fraction bar always means division. Okay, so 25 divided by 5 would give me 5. So we know that our height is 5. All right, guys, hey, good work today. If you have any questions about anything we went over today, please feel free to email me. Remember, this is just session 1 of this video. All right, have a good day.